So here we have a vector in Rn, and we have two norms on Rn. The first norm is norm 2 and the second one is norm infinity. Norm 2 of vector x is square root of each component square, the sum of each component square. Norm infinity is the maximum of the entries of vector x. We need to show that norm 2 is less than square root of n times norm infinity, and we need to find an example for which the equality holds. So we do it by definition. Norm 2 of x by definition is square root of x1 square to xn square. Okay. Now look at x1 square or for any I from 1 to n. We have xi square is absolute value of xi square. Right. This one is less than or equal to the square, put it still here, maximum of xi's I from 1 to n square. Recall that this is true is because first of all xi's is less than or equal to maximum of xi. Right. And the second is true that these numbers is both of these numbers are positive. Max xi's is non-negative, so we need this condition, otherwise it might not be true. Recall we have example before that. For example, minus 5 is less than, say, minus 1, right? This is because this number is negative, and we only have the function is increasing on the function absolute value of x. So f of x, absolute value of x is increasing say 0 to infinity. That's why we can use, we have this inequality. Okay, and what does that mean? This number, the maximum of the absolute value, is exactly by definition the norm of x, norm infinity of x, this square. What? Okay. Therefore, we can continue evaluation from here. So we have this one less than or equal to, so this is norm infinity, x1 square is less than norm infinity of x square, right? And we do it for all xi's. And this is the square root of n times norm of x in norm infinity of x square. N is positive, right? So So this is square root of n times square root of x infinity square. So this number is also non-negative, so this is times norm x infinity. Therefore we have norm 2 of x is less than or equal to square root n norm infinity of x. We have equality, so this is equal if and only if the equality is here is true. This is true if and only if this is true, right? This means that x absolute values of xi is the same as maximum. This means that absolute value of xi is the same as maximum of absolute value of xi for all I from 1 to n. This is true if this condition is true. And this condition is true means that x is just a vectors with all the entries of x, all the entries of x have the same values, right? So that means that all components of vector x the same or have all the components I have equal. I need to. So we can just give an example. For example, vector x. So it just means have the same absolute values. It doesn't have to be exactly the same number. For example, 3 minus 3 is still the same. So vector x can be vector 3 minus 3, 3, 3 minus 3, whatever. 3. So it is a vector in Rn, right? Put transfer for column vector. So we have norm 2 of x is square root upon 3 square, right? Times plus 3 square plus 3 square, right? Or minus 3 square, but it's still equal to 3 square. And it is the same as square root of n times 3 square, right? So it's 3 root n. And this is norm 2 and norm infinity of x. What is this? This is the maximum. Norm infinity of x, yes, the definition is a maximum of the absolute values. Maximum absolute values of xi from 1 to n. So it's a maximum of 3. So maximum on 3, right? Because the absolute values are on 3, which is 3. So the inequality now become equalities with this, which means that we have this condition. Therefore, this norm 2 is 3 root n. This is root n times 3 is the same. So yes, we get an example where the equality is true.